In the late 1980s, computer programming was an unforgiving environment defined by the strict requirements of the hardware. Computers only understand machine code, a binary stream of ones and zeros. To communicate, humans had to use rigid translator languages that functioned as a direct bridge to that mechanical reality. Older compiled languages, like C++, forced the human to work on the computer's terms. They required dense syntax and a mastery of intricate, punishing grammar rules. These systems utilized a compiler to translate an entire codebase all at once. A single typo on one line would cause the entire build process to fail, forcing the programmer to hunt through thousands of lines for a single mistake. Because these languages prioritized the execution speed of the machine over the convenience of the developer, they created a massive technical barrier for anyone trying to enter the field. Dutch programmer Guido van Rossum spent the late 80s dealing with the friction of these hyper-rigid legacy languages. He argued that a programming language's primary design goal should be human readability, favoring plain English logic over rigid computer syntax. This new project was a philosophical mission to bridge the gap between human thought and machine execution. When van Rossum released Python in 1991, the name was a tribute to the British comedy troupe Monty Python's Flying Circus, a choice meant to signal that coding could be approachable. To make the language more flexible, Python utilized a different architectural approach than its predecessors. It was an interpreted language. Rather than digesting a massive block of code all at once, an interpreter reads, translates, and executes instructions line by line. This allows developers to test and debug on the fly. If there is an error, the code runs perfectly until it hits the specific mistake, significantly accelerating the human workflow, even if the machine takes longer to process it. Traditional languages are often visually cluttered, relying heavily on curly braces to group different blocks of logic together. Python removed those braces entirely. In their place, it used mandatory spacing called indentation to organize the code. This rule is absolute. If a developer accidentally misses a 4-space indent, the program will instantly crash. By making whitespace a requirement of the grammar, van Rossum physically forced all developers to write code that was universally readable by others. Older languages use static typing, where a programmer must manually define if a variable is a number or text before the computer will accept it. Python uses dynamic typing. It figures out the data type automatically the moment the code runs. This allows variables to change data types on the fly. Swap a number for a text string mid-script, and Python adapts without an error. By automating these data definitions, Python removes a repetitive layer of manual labor. This reduction in overhead makes it a highly efficient environment for rapid prototyping and creative experimentation. As the language grew, it relied on the Python virtual machine to act as a middleman between the code and the computer. This enabled a write once, run anywhere philosophy. A single script could run on Windows, Mac, or Linux without any modifications. In 2008, van Rossum took a major risk by releasing Python 3. He intentionally broke compatibility with older versions to fix deep design flaws, forcing the entire industry to eventually rewrite their codebases. This decade-long transition was a commitment to the language's core integrity, sacrificing short-term stability to ensure the code remained clean and logical for the future. Today, Python is the standard for data science and artificial intelligence. In these fields, the mathematical logic is already immensely complex. Researchers use Python because its clear syntax ensures the language doesn't add a second layer of difficulty to their work. Under the hood, Python is still inherently slower for a computer to execute than a compiled language. But by prioritizing the human mind over the machine's speed, Python enabled a global explosion of development. It proved that when you minimize the friction for the creator, you maximize the scale of what they can build.